welcome back to the third video on this lesson, lesson 8, derivative of a function. So I hope that you have already watched the other two videos, previous videos. I'll leave it in the description. So let's have some examples. Let's have example number 1. Example number 1, given f of x equals to x squared plus 5x minus 1 at x equals to, find the following. A, we need to find the point, okay, at x equals to. B, find the derivative of the function. C, what is the slope of the tangent line at the given point. And D, what is the slope of the normal line at the given point. We'll start with A. To solve the point xy, we're given the function and also a value of x. So to find the value of y, we simply substitute the value of x in our function, because take note, f of x is actually y. Okay, so at x equals 2, we'll have f of 2 equals 2 times 2 squared plus 5 times 2 minus 1. And this will give us y equals 17. Hence our answer, the point being 2, 17. This is our ordered pair. Next, we'll have question B. We are asked to find the derivative of the function. So take note, the derivative of the function is actually just the form which we are going to use later on to find the slope of the tangent line. So how do we find the derivative of the function? We're going to simply apply the definition. Okay, so we'll use the definition of a derivative of a function. And we know that this is the definition of the derivative of a function. We have the dy dx equals the limit of f of x plus h minus f of x all over h as h approaches 0. Again, you must remember this definition to find the derivative of the function. So we substitute now the given function to the definition. So we'll have this. Okay, so it might be confusing, but again, we just use the function, and our function is 2x squared plus 5x minus 1, which is actually our f of x. Okay, and here, the red part, instead of having x as our variables, we have now x plus h, because again, the input value at the first term is x plus h. So we have 2 times the quantity of x plus h squared plus 5 times the quantity of x plus h minus 1. Then we simplify further. So yes, right, we expand our x plus h squared. We have now x squared plus 2hx plus h squared. Then we multiply 2. So we have, or distribute 2 rather. So we have now 2x squared plus 4hx plus 2h squared plus 5x plus 5h minus 1. And we also took down the grouping symbol, or symbols rather, and we distribute the negative sign in the second term. So that's why we have negative 2x squared minus 5x plus 1. Okay, then we combine. So as you can see, we can cancel out 2x squared because we have positive 2x squared and negative 2x squared. We can also cancel out 5x, and we can also cancel out 1. So what remains is 4hx plus 2h squared plus 5h. And then we factor out h, because that is the common factor. Again, common factor is h. So factoring out h, we have h times the quantity of 4x plus 2h plus 5 all over h. Then we cancel out h, and this will give us 4x plus 2h plus 5. And now we can substitute. Again, this is still a limit, so we will substitute 0 to our h, and this will give us 4x plus 5. And this is our derivative. Next, let's try to solve for the slope of the tangent line at the point. Okay, so how do we solve for the slope? We know that the derivative is already 4x plus 5. So this is the formula that we're going to use, okay, to determine the slope of the tangent line, because again, dy dx is actually the slope. Okay, this is already the slope, but we need the value of x to really determine the answer. So we know that x is equals to, okay, so we will substitute 2 to our formula, dy dx, this formula here, and we'll have 4 times 2 plus 5, which will give us 13. And this is the slope of the tangent line at the point 217. Next, we're going to find the slope of the normal line. So now we have this term normal line here, and maybe it is kinda new to you. When we say normal line, it is actually the perpendicular line, okay, that passes through the tangent line at the given point. So for example, if we have our graph here, let's say this is our graph, and then it happens is that this is our tangent line. What is it? Let's have another color. Let's have yellow. So let's say this is our tangent line. This is our point here. Okay, so the normal line, again, this is the tangent line to the curve. So the normal line is actually the perpendicular line that passes through the tangent line and the given point. So this is actually the normal line. Let's have a lighter color here. Okay, so this is the normal line. This is perpendicular to the tangent line. Normal line. Okay, so take note that the relationship between the normal line and the tangent line, they are perpendicular, and this is in notation best represented by this formula here. The slope of the normal line is actually the negative reciprocal of the slope of the tangent line. So take note, dy dx is the slope of the tangent line. So some notations use m for slope. So the slope of the normal line is just the negative reciprocal of the slope of the tangent line. So for our solution, we simply use the result in our C to get its negative reciprocal. Okay, so we know that dy dx is actually our slope of the tangent line, which is 13. Hence, the slope of the normal line, okay, normal line is the negative reciprocal of the slope of the tangent line. So we have negative 1 over 30. So we're done with number 1. Let's have example number 2. Okay, so for example number 2, we have this function here, f of x equals x plus 2 all over x minus 1 at x equals 0. So we are asked to find the point, the derivative of the function, and then we have now the term equation of the line, okay, and we have equation of the tangent line rather, and then equation of the normal line. So it's not anymore the slope. Let's proceed to the solution. Okay, so we're asked to find the point. Again, if it's just the point, we simply substitute because we have already the value of x here. We know that x is 0. We can substitute 0 to the function, and this will give us negative 2. So our point is 0, negative 2. Then we have to solve for derivative of the function. So again, derivative of the function, we will use the definition. So this is our definition, limit of f of x plus h minus f of x all over h as h approaches 0. And then, okay, so we substitute the function. Okay, so f of x is x plus 2 over x minus 1, which is this. And then we have the red function here representing the x plus h input. So instead of x, we have now x plus h plus 2 all over x plus h minus 1. Okay, so here we'll do some algebra magic. Okay, so algebra magic here. So we will find the LCD. The LCD is actually x plus h minus 1 times the quantity of x minus 1. So there is actually a neat technique here. We simply multiply, okay, a factor which is missing in the denominator of the other term. So for example, we have x plus h minus 1 here, okay, here, but we don't have x minus 1, which is found in the second term. So we multiply x minus 1 all over x minus 1, because again, this is just 1. This is simply 1. Then, for the other term, the second term, the blue term, okay, so we are lacking x plus h minus 1. So we multiply x plus h minus 1 all over x plus h minus 1. And this will give us this function here. Okay, so I have already multiplied, distributed the factors. We distribute. So x times x, we have x squared, and we have x times h squared, x times 2 plus 2x, and we have the minus 1, so minus x minus h, and times negative 1 times 2 is minus 2. Okay, all over the factor here, so we have x plus h minus 1 times the quantity of x minus 1. Then for the blue term, so same idea, we have x times x, we have x squared, x times h, we have hx, minus x, and we have x times 2 times x, we have 2x, 2 times h, 2h, 2 times negative 1, negative 2, all over. So we have the LCD x minus 1 and x plus h minus 1. Okay, so since they have the same denominator, we can actually combine. So now we have the same denominator, we can now combine this. So, and then we can, after combining, we can actually bring over h to the denominator, because again, it's just reciprocality, properties of reciprocality. So we have now h times the quantity of x plus h minus 1 times the quantity of x minus 1 in the denominator. Okay, and then we have minus here. Take note, this is minus. So we have the grouping symbol because we are actually subtracting the entire group. Okay, and this will give us, okay, so we take out the grouping symbol and change the signs. So from, take note, we have plus, minus, plus, plus, minus in the second term. Now we have minus, plus, minus, minus, plus. So the signs changed because we distributed the negative side. Okay, then we simplify. We can cancel out x squared because we have x squared minus x squared. We can also cancel out 2x. We can cancel out 2. Okay, what else? We can cancel out x. And what remains is h. Okay, we can also cancel out hx. We have h, negative h rather, and then we have negative 2h. And then we can combine. We have negative 3h, but we can cancel out h. This will give us negative 3 all over the LCD. Here we can now substitute because we cannot cancel out anything. So we can substitute 0 to h. This will give us x minus 1 times x minus 1 in the denominator, and we can combine it, and we have negative 3 all over x minus 1, rather quantity of x minus 1 squared, And this is our derivative. Okay, this is our derivative. Okay, so let's continue. We have now C, and we're asked to find the equation of the tangent line. So take note, this is not the slope, but rather the equation. And the equation of the tangent line, we just use the point slope formula. Okay, so what is the point slope formula of a line? It's just y minus y sub 1 equals the slope. Take note, m is the slope, times the quantity of x minus x sub 1. So the y sub 1 and the x sub 1 here are actually the given points. Okay, the given ordered pair x, y. Okay, so from the previous solution, we know that x sub 1 is 0, and yeah, let's go back. What's the point? Yeah, and we have x sub 1 here being 0 and y sub 1 being negative 2. Okay, so from there, we have here x sub 1 and y sub 1 negative 2, and we know the slope of the tangent line. We have m sub t representing the slope of the tangent line, or dy dx. You can use dy dx. So this is actually dy dx, and hence we can substitute. Okay, substitute the values in the point slope formula. So we have y minus the negative 2 equals negative 3 times the quantity of x minus 0. And if we simplify the equation, we'll get y plus 2. Negative times negative is positive. And x minus 0 is just x times negative 3. Then we use the properties of equality, put the values, the variables rather, and values to the left side of the equation, and at the right side it should be 0 because we're using the standard, the general form rather, the general form of the line. It's the general form. Okay, we have the general form, which is ax plus by plus c equals 0. That's the general equation or general form of a line. And this is our equation of the tangent line at 0, negative 2. And lastly, we have the equation of the normal line. Okay, so we will use the point slope formula again because normal line is still a line. So the difference between the tangent line and the normal line is actually the slope. Okay, so we will use the same formula and the same points because we know the point already from letter A. Rather, this is actually letter B. And again, we know the slope of the normal line is just the negative reciprocal of the slope of the tangent line, or we have negative 1 over mt. Okay, so we have, since mt is negative 3, we will have negative 1 over negative 3, which is 1/3. Okay, then we use the point slope formula. We substitute the values of x sub 1 and y sub 1, and we have this. Okay, simplify the equation. We have y plus 2 equals 1/3 x. We multiply 3 both sides, so we have 3y plus 6 equals x. And instead of using the property in such a way that this becomes negative x, I go with the other way. So I transferred it to the right side, so we have negative 6 and negative 3y. Then I use symmetric property. Okay, so there's actually a missing line here. So we have 0 equals x minus 3y minus 6. Then using the symmetric property of equality, we have now x minus 3y minus 6 equals 0. And this is actually the equation of the normal line. Okay, so here is the graph of the function. Okay, so as you can see, this is our function here, and our point is 0, -2, which is this part here. Okay, and we have our tangent line and normal line. So the tangent line is the green one. This is the tangent line, equation of the tangent line rather, and this is the equation of the normal line. Okay, and obviously from our solution, we know that the tangent line, the slope is -3. And as you can see, the line is going downwards, decreasing. That's why it's -3. Take note, if the slope is negative, then it's decreasing, it's going downwards. And for our normal line, we know it's 1/3, it's positive, so it's increasing. Okay, and observing the graph, you can actually see that the tangent and the normal line are perpendicular to each other. Okay, so that's the relationship between the tangent and the normal line. So this is the function. We have the red graph here. This is how we visualize the derivative. So at this point here, at this instant rather, 0, -2, the slope is actually -3, or the derivative is -3, indicating that the function is decreasing at this juncture. Okay. So in the next video, there will be a video after this explaining the differentiability and continuity. Okay, so, and we will have an example. Okay, so see you in the next video. Bye bye.